question is, what was the last step in the previous lecture in your group? Yes. What is the question about the case number 3?
Добрый день, Екатерина Павловна.
Здрасте.
Смотрите, вопрос такой. А вот вектор Q, когда мы рассматриваем матрицу ожидания инвестора, мы эти доходности как определяем? Мы должны сами определить, насколько один актив будет лучше другого, или на основании рынка?
На основании рынка получится модель CPM.
Да, вот. То есть мы должны сами как-то сделать вывод по тому, насколько ретерн одного актива в день будет больше, чем другого, да?
Да. Более того, вы еще должны быть как-то обосновать.
Угу. А для обоснования можно использовать какой-нибудь фундаментальный анализ там по коэффициентам?
Что
и
хотите,
прочее?
да. Ну и нужно использовать фундаментальный анализ данных.
То
Но
есть как угодно просто сравнить две
нет, если
компании.
бы ситуация была иной, я бы вам сказала, сходите, выгрузите данные с Томпсона. Но теперь я вам не могу так сказать. Поэтому
Потому что
придется...
у нас его нет, да?
Ну, его не только у нас нету. Да.
Ну да, я понял.
Вот, поэтому как
Теперь мы
бы...
сами все делаем.
Поэтому вы делаете все сами, да. Ваша жизнь несколько усложнилась.
Хорошо.
Нет, ну масса площадок предлагает какие-то инструменты.
Прогнозики.
Вот. Единственное, что вы должны понимать, что то, что вы получите, оно должно отличаться от модели CPM. Потому что модель CPM предполагает, что у вас никаких идей нет. И тогда вы пользуетесь тем, что вам предлагает рынок. Вот.
Поэтому и уточнял.
Да.
А количество views это, ну, любое может быть? Или...
Количество views любое у вас может быть, да.
Да, то есть если я уверен в 3, то делать 3, а если там...
Если вы
10,
уверены в
10.
3, то делаете 3. Ну, понимаете,
Да, я понял.
конечная цель третьего кейса – это, соответственно, вам же нужно будет выстроить 2 прогноза по портфелям. Один базируясь на одних данных, а другой базируясь на других данных. И если вдруг окажется, что у вас эти прогнозы одинаковые, это вы провалили кейс.
Ну да, то есть и тогда наши ожидания бесполезные получатся.
Да, кажется, что это бесполезно. Ну ничего, с понедельника у вас все? Отсидка на диванах
Вроде...
закончилась?
Ну да, походу.
Можно и так выразиться, да?
Да. Хорошо, спасибо.
Пожалуйста. Траектории строятся по любому количеству Антонова. Это точно совершенно. Вы просто, вероятно, не понимаете, как они строятся. Это утверждение, судя по вашему вопросу. Я не понимаю. Excel позволяет, Excel все равно. Либо вы требуете от него что-то невменяемое. Excel позволяет, ему вообще все равно. Там 40 тысяч столбцов поддерживается. Поэтому нет. Это не так. То, что вы не справляетесь с Excel. Каких шагов? Давайте мы пример доразбираем. Исаева, может, я не понимаю, что вы спрашиваете. Либо выйдите в эфир, как Ливанов, и давайте мы обсудим смысл вопроса. Каких шагов, о каких шагах идет речь? Ничего не сказала рыбка. Рыбка молчит. Абсолютным способом вы не можете сравнить, потому что у вас есть матрица link matrix, и в link matrix вы ставите 1, 0 и минус 1. Соответственно, 1 это тот, кто превосходит, минус 1 это тот, кого превосходит, и 0 это тот, кто не участвует. Это сравнение, а не задача конкретной доходности, которая таргет будет. Я понятно объяснила? Okay, I think we will finish with example. And after that, we will finish with example in case number 4. I think we have to go back to case number 3, because as I understood, we have some difficulties with understanding what's going on in case number 3. In case number 3, you have two variants of expected return in framework of your portfolio. In first way, you will use CAPM model. Second way is to use Black-Litterman model. So after implementing these two models, you will have two possible expected returns. And the key moment is to construct the forecast, the trajectories using Monte Carlo approach in case number 3 for the particular assets using CAPM model, and for the portfolio using two approaches, CAPM model and Black-Litterman model. And you will construct the trajectories for the portfolio. And after constructing all the trajectories, you will as a result, you will get the forecast for the portfolio, for the pricing for your portfolio of shares. Do you understand me? Yes or no? This is about case number 3. The construction of trajectory is absolutely the same like in Monte Carlo approach in case number 4. These are the same construction. Okay, if you want, I can finish the example from the very end of the previous lecture, and we will be back to the case number 3, and I explain one more time. Yes, please, about what? About case number 3? Coming back to case number 3. About the trajectories, am I right? Silence. Okay, but what's about the third case? About the constructing of trajectories in case number 3. Okay. Okay, I understood. And I want to say you have the same thing about the defending the case number 3, because the deadline on case number 3 is the 16th of April. This date will not be changed. Please pay attention. So due to the fact that starting from Monday you are offline, of course you will finish the third model online, but the whole university offline, no problem to go and to defend the case number 3. Pay attention that the deadline will not be changed. It's 16th of April. You will be online and no problem to defend the case online. I think it will be a bit difficult to be in a university in Russia. For you, you will defend the case online. Or you're talking about something else, about the deadline for case number 3? What is your question? Okay, let's go back to the end of the previous lecture. What was the last step in our example? Okay, thank you. And we discussed case number 4. Am I right? The end part of the case number 4. Yeah. Okay. Let's finish with case number 4. Next, we will be back to case number 3. And after that, if we will have enough time, we will start case number 5. This is the algorithm to end for today. Okay. Okay, we did the table. And after that, we should... So we did the table to construct, no problem to do it. Next step is to get together the random numbers using the Kholetsky factorization. So this is our Kholetsky factorization. And I want to get together my random numbers because in the portfolio they must be connected. And to do it, we will use Kholetsky factorization as I told you before. So how to do it? We should multiply this Kholetsky factorization to the random numbers. In the portfolio, we have two assets. That is why we will do the next step. Okay, maybe here. So the matrix will be absolutely the same, but they must be connected. So I think I can copy. Here I should multiply my matrix to the random numbers and to connect them, to make them get together. And I use multiplication of matrices, the function mmult in English, and it will be like this. Let's go here. So I need my matrix. Do not forget to fix it. And we should multiply it on random numbers, like this. And I got it. Now my random numbers here, they are connected. So I just can do like this. I don't know if I can. Yes, I can. Very good. Yeah. Now I constructed the table with my connected numbers. Now in this new table, in this second table, my random numbers, this is the table number 2 about the random numbers. And here they are connected. The first table is just the random numbers. And in the second table, the random numbers are tied with the help of Haletsky factorization. And these numbers we should use in our portfolio. We should use them in our portfolio to construct the trajectories of the portfolio. Next, let's get them together. Let's connect them. We need to construct the table number 3. To do it, we need the information about my construction. So I have the z, epsilon, delta t, and delta t will be equal to 1 if we want to calculate 1 day value at risk, so it will be 1 divided to 365. Do not forget that delta t must go to infinity, it must go to 0. So this step is okay, we can use it. In case you want to construct, for example, value at risk for a week, of course, if you will divide this number to 365, or here you can use the number of trading days. If you want, the number of trading days will be like this. It will be absolutely the same, but pay attention. You should take into consideration that delta t must go to 0. This is the assumption to implement eta formula. And if this is not fulfilled, it means you just should increase the number of steps to make assumption true. To make assumption true, it must go to 0. So let's construct the trajectories. It will be absolutely the same. Here are my random numbers. And I don't know, maybe I need this information, so I need sigma, I need mu, and I need delta t. This is mu of Coca-Cola, and this is mu of PepsiCo. So I need it. Okay. For example, I'm going to construct the trajectories here. So mu of Coca-Cola, mu of PepsiCo, also I need sigma. And I need formula and delta t. Okay, so the number will be the same, so I'll copy. And now I want to implement this formula, but I need the initial share price for mu and for PepsiCo. So I will write it here, Coca-Cola and PepsiCo, last price. Okay, historical data, I need the last prices. Okay, here we are. Oops. Like this. I will check, am I right? First Coca-Cola and next PepsiCo. First Coca-Cola and next is PepsiCo. Yeah, it's okay. So this is the price we are going to use. As I told you before, the Monte Carlo method it uses ITO formula, and it suppose we have a Markov process. It means we just use the share price on the last step and do not take into consideration how did the share move to this price. We are not interested in it. The assumption is we have a Markov process. It means we are not taking into consideration all the previous steps. So, okay, so let's do it. We need the initial price like this. For example, the first price will be Coca-Cola, and the second will be the PepsiCo. Here, what should we do? We should add change in price to the previous price. So previous price plus change in price. We should use mu of it's Coca-Cola, fixed it, plus multiple to share price to change in time, fix it, plus we need sigma of Coca-Cola to share price, sigma of Coca-Cola to share price, and to the z, which is equal to epsilon. Epsilon we should take here, so pay attention, we will take epsilon. So in our case, this is a inverse normal distribution from this random number. Oops. And multiple to delta t, fixed it, power z 0.5, so it means we should calculate square root of it like this and continue. We should do the same to PepsiCo. We should take share price plus change in price. So here we should use mu multiple to S. It means share price to change in time, plus sigma to share price and binary process, which is epsilon. One more time, inverse normal distribution. From this, they are tied now, and to step in time, power square root of step in time, fix. Oops. We have negative numbers here. Oops. Okay, I understood. Here we got the random numbers. Okay, let's change. No problem to do it. We just move here like this. Let's do like this. Norm inverse distribution. From random number. It will be epsilon itself, because after multiplication we got inverse, negative numbers, and here we just should change them. Like this. So it will be epsilon itself. Now we will not write norm inverse because we have negative numbers in correlation matrix, and due to this fact, okay, let's copy and paste numbers. So here we have this. It will be epsilon itself. So here we will have epsilon, which is tight. Everything is okay. And now without inverse, just here the initial numbers of PepsiCo and Coca-Cola and PepsiCo. And now epsilon here will be just epsilon itself without normal distribution. So we need share price plus change. Change, it will be mu for Coca-Cola multiple to share price multiple to step in time fix plus sigma for Coca-Cola multiple to share price multiple to the z, which is epsilon, but in this case without inverse because we already had used it. We already calculated it. It will be epsilon and multiple to square root of step in time. And multiple to square root of step in time. Fix. Okay. Absolutely the same for PepsiCo. We use the initial share price plus change. Change is mu for PepsiCo, fix to share price, to step in time, fix plus sigma to epsilon. Epsilon we should take from table number 2. This one. And square root of step in time. Fix. Okay, we got trajectory. This is the trajectory of a portfolio. So to calculate the trajectory, and now they are tight in our construction, so everything is okay. And if we want to calculate the trajectory of the portfolio, we should take into consideration of cost weights. And it will be here, and it is one trajectory of the portfolio. So to calculate all of them, you should do the same steps to the rest part. And after proceeding with all the steps, so I think you should do like this. I don't know, I can try to continue. Is it possible? Oh, no. And if I will do like this, oh, it's okay. And now you can continue. I don't know, will it work or no? Maybe yes, maybe no. Let's try to continue. Will it be automatically or no? I don't know. Yeah. It works, as I can see. Let's check. Is it okay? Here. Just let's check. Is everything okay? If we will do like this. Here everything is okay. What's about? Yeah, it's okay. It works. Good. So it means we can continue. And we can do like this. Oops. No? Oh, it... Oh. Oh. Not enough. Okay, let's continue. Okay, so we had calculated some changes. Okay, what's the idea? The idea, now we have constructed the trajectories for the portfolio, and now you can estimate the value at risk using, doesn't matter which method, but to calculate the return, you should understand that you should take the last step and the first step and find the difference. It will be the return. So here you can get the new returns. It will not be problem. And for example, if you want to get them, the new returns, you just should take the last value minus first and divide it to the initial value. It will be your returns. Oops. For both shares. And now, of course, you should separate PepsiCo and Coca-Cola. You should consider them separately because this is for PepsiCo and this is for Coca-Cola. Due to low volatility, the value at risk will be very, very, very low, of course. And I think no problem to separate them. And after doing this, you will have two construction, and it allows you to estimate the value at risk for the portfolio using, I don't know, analytical method or historical method. Doesn't matter. If you want, I don't know, to estimate the new returns, you can do like this. Because you should select. Oops. Not like this. And now you can just make filter like this. I think it will be better to take on your sheet because it will a bit problem. And now, for example, you can filter. For example, and for example, you want only one. And this will be for PepsiCo. You just can, yes, you can copy. It will be for PepsiCo. The new returns. Oh, first was Coca-Cola. That's the problem. Oops. So this is Coca-Cola. And now for PepsiCo. Like this. These are new returns for PepsiCo. Now you have the portfolio, and you can estimate value at risk for these simulated trajectories using any approach, historical or analytical method. For example, let's use, I don't know, if we want to use analytical method, we should, like here, like we did for value at risk for the portfolio, first of all, you will have to construct the correlation matrix of these new returns. You should calculate the weights. You can use the same weights, and it allows you with these new returns to estimate value at risk. You can check the new trajectories. They will have, for example, normal distribution if we did everything correctly. It must be okay. So like this. So this is like this. And as I told you, you should use Peirce criterion and for this also. But it had normal distribution, so it's not necessary. But this is how it will be work. So I will stop the demonstration. What does it mean to explain the Haletsky factorization? It's just the algorithm how to calculate the square root of a matrix. You have the formulas, and the task is just to implement them. I have shown you the formulas, and you can do it one more time. What does it mean to explain how to implement the formulas? You are a third-year student in the university, and I really hope you are able to implement the formulas you can see. Really, I really suppose you can do it if you are a third-year student in the university. No problem to substitute in the formula and to calculate. So you got the new values, and you got the new returns. These new returns allows you to construct to calculate the new value at risk using the same approach we had used on previous step, historical or analytical. Any questions? I have shown you how to get the new returns. Any questions? Do you want to ask something? No. Okay, in the case number 3, if we will go back to case number 3, in the case number 3, if I will go back, you will have the values of mu, and the values of mu will, in your case number 3, are calculated using two approaches: Black-Litterman model and CAPM model. It means you will be able to construct the trajectories using the same approach, the same Monte Carlo approach, but using two initial data. In the first step, in the first case, your initial data based on expected return, which was calculated with a CAPM model. On the second in the second case, your expected return were calculated with Black-Litterman model. So it means you have two initial data and you will implement it. But pay attention that I had calculated these trajectories for 1 day step and time. Your forecast will not, of course, it's senseless to construct for forecast for the portfolio for 1 day. You will use another step in time to construct the trajectories. I hope you can use, I don't know, 2 weeks or 3 weeks. So in this case, it will be like this. but it is too much. It does not go to 0. What should you do in this case? In this case, to increase the accuracy, if you want to construct 4 days forecast, these are the number of trajectories. These are the number of trajectories. So here, the number of trajectories will be the same. But to construct, to make forecast more accuracy and to implement either formula, you should make more steps here. You should have to make more steps for, I don't know, maybe it will be 1,000 and or 2,000 steps for each case. If we want to increase the accuracy, because it must go to 0. 1%, okay, it's rough, but it's enough. This is the key moment, so it means here you have to do more steps. You have to do more steps. This is about case number 3. And this is how to construct the trajectories in case number 3 and what should you present as a result of case number 3. So if somebody wants to ask something, I can switch on your microphone and we can discuss anything about case number 3 or case number 4. Please think and tell me, do you have any questions about the case number 3 and case number 4? In case yes, let's discuss it. Okay, I suppose it means you have no questions about the case number 3 and case number 4. Everything is clear because case number 4 mostly duplicate the case number 3 in the part of constructing the trajectories. But in case number 4, you just will construct 1-day trajectories. In case number 4, you have to make more steps. That is why the price for case number 3 is 16 points. And pay attention to make 2 weeks forecast or 3 weeks forecast. You have to increase the number of steps and to do like this. Any more questions? Does somebody want to ask something about case number 3 or case number 4? Yes. For case number 3, you have to construct 3 models. Using CAPM model, you will construct trajectories for a single asset. You have 7 single assets. So you will just construct a forecast for a particular asset. Step number 1. Next, using CAPM and Black-Litterman model, you will construct a forecast for the portfolio. You will construct a forecast for the portfolio because expected return you got in framework of Black-Litterman model will only work in framework of this model. So it means it's only for the portfolio. Trajectories for a particular assets, forecast for a particular asset. Do not forget that you should be able to explain your forecast. The probability you are waiting the share price will go up or will go down, why, and so on. And in Black-Litterman model also. And of course, you should use the weights with the best shape ratio for the CAPM model and for Black-Litterman model separately, because these are it must be 2 different portfolios, and you will calculate the weights for the Black-Litterman model and for CAPM model using the approach of maximizing the Sharpe ratio. Yeah, it's okay for 10 days. 10 working days, it will be enough, yeah. It's not okay to make the forecast in case number 3 for 1 day. It's not okay. And for 2 days also. 10 days to me, it's enough, yes. It's not senseless because 10 days, it's about 2 weeks. Yeah. Any more cases, any more questions? If you want to ask something, please do it and I will try to answer. Otherwise, we will have a problem when you will try to defend the case. If no questions, I will go to case number 5. Okay, so I think it means you have no more questions. Of course, because you want to construct the trajectories for the portfolio. It's absolutely the same approach, which is why I have told that the case number 4 duplicate case number 3 in the part of calculating the trajectories. Which is why the price for case number 4 is just a gift. The whole work were done in the case number 3, and it's very easy to get 10 points for case number 4 for same job. Absolutely, for same work. You should do the same steps. You just duplicate, and when you, in case number 4, it's just to calculate value at risk, how to do it. But all the algorithm to constructing and to implementing Monte Carlo approach is the same for case number 3 and for case number 4. And Kalecki factorization is the part of the case number 3 and case number 4. This part you will use to construct the trajectories for the portfolio, not for the particular asset. Matrix P is the link matrix, and in the link matrix you are yes, you should use the returns for Q. I will open the presentation. Wait a minute. I don't know where is presentation in English. Okay, we'll open in Russian. It does not influence, I think, the result. So here, this is the link matrix and this is the views. So link matrix is tied very closely to Q, because here we told that MTS goes faster than Yandex. And this is the link between MTS and Yandex, and Polizolta does not involved in it. Here, the second row represents the connection between Yandex and Polizolta. Yandex goes faster than Polizolta, and this is the speed. Okay? Or did you ask something else? We need to forecast. Yes, you can use. If you remember the last year, we had studied a RIMA model to construct a forecast. Do you remember it? ARIMA model to construct the forecast of a share price. On probability theory and statistics. I don't know, did you do it with Galina Vladimirovna or not, but group number 9, it will be the best decision, I think, to construct a forecast with the help of linear autoregression model we had studied in previous year. We didn't study anything useless. So if you don't find the information in the net, you can construct a forecast for share price using ARIMA model, using autoregression model we had studied a year ago. I think this will be the best decision. And this is the answer to all of you, how to get the new views. Did I answer your question? Yes. So open the previous year studying, find ARIMA model, and you will be able to construct a forecast like we did last winter, on theory of probability and statistics. This is how to get a forecast, and you will using previous data, because you can do it, and based on it you can be able to get Q, because you need forecast share price, you need something about Q. For example, like this. This is one of the ways you can use to get the result. ARIMA model is very good model to construct the forecast. It's one of the best models, and autoregression models, they work very, very good. Okay, any more questions? You should check normal distribution to apply analytical method in case number 4. In case number 3, you shouldn't use it, because the normal distribution is inside the eta formula when you are constructing the random values of epsilon. So the answer to your question is no. Any more questions? Monte Carlo approach is the way to construct of trajectories. I just told you, you will construct the trajectories using eta formula, but it's the same. Monte Carlo analysis, Monte Carlo approach means to construct the scenarios. We discussed in case number 3 that we should construct the trajectories. Maybe I did not use the words Monte Carlo approach, but it means you should construct the scenarios for trajectories, of share prices. What do you want to hear? What do you want to know? Okay, thank you. In the rest of 15 minutes, I think we can start with case number 5. But before we will start with case number 5, I want to tell you that you can defend the case number 3. Case number 3, I think what the last day will be. So you have seminars this week. This Saturday, you have seminars next Saturday. And on the week starting from 11th of April till 16th of April, if you want, if you want to defend the case, let me know and we will check the day and you will get the time to defend the case. Because you don't have seminars or lectures in the university. This week I will have, of course, and I will be in the university. So if you want and if you will decide to defend the cases, the case number 3 starting from 11th April until the 16th of April, till the deadline, I'm talking about this week. So let me know and we will choose the day. Did you understand me? Yes, but pay attention. You shouldn't go all of you at the same day. And we also should take into consideration the Russian groups because they will have the same situation. On this week, nobody of you will not have lectures or seminars. And it does not influence the deadline, as you understand. So it means we should go get together and we should decide which day we will defend the case if you want. Is everything clear? At this moment, yes, okay. In case number 4, I want to add one more. Wait a minute, please. In the case number 4, I think you understand you have two portfolios. Also, you have two portfolios, and you have to calculate value at risk for two portfolios. You will have the weights for the CAPM portfolio with best Sharpe ratio from case number 3. You are calculating value at risk for it. You're constructing trajectories. Next, you have the weights for Black-Litterman model. You have the weights for this model. You have expected returns. You are calculating trajectories and calculating value at risk for this portfolio also. Did you understand me? Silence. Okay, I think it means yes, you understood. Трифонова, что вам на русском повторить? По поводу кейса 3 или кейса 4? Что у вас var будет для портфеля, для двух портфелей посчитан. Вы в третьем кейсе посчитаете два портфеля, максимизируя Sharpe ratio для модели CAPM и для модели Black-Litterman. Соответственно, у вас будет два варианта expected return и, соответственно, два портфеля. Вот для каждого из них вы считаете var в четвертом кейсе. Ну, то есть в четвертом кейсе вообще уже ничего делать не надо, все до этого будет сделано в третьем кейсе. Только новые траектории надо будет построить, потому что в третьем кейсе они будут двухнедельные, а здесь однодневные надо будет построить и посчитать по ним var. Кейс номер 4 – это просто подарок 10 баллов всем вам. Это совершенно серьезно. Ну, после того, как вы помучаетесь серьезно в кейсе номер 3. А четвертый – это просто гифт. Там делать уже ничего не надо. Ну, var посчитать. Понятно, что я сказала? Yes, success. Так. We have 10 minutes, and I think we can start with case number 5. Or any more questions or no questions? Okay, I mean, it means no questions. Okay, so I think we can start with case number 5. Yeah. The task of case number 5 will be to estimate the option price using different models. The additional difficulty in case number 5 the previous year did not have is to estimate so-called implied volatility or option volatility. I think due to this fact, we will adjust the total number of points for case number 5, because I thought it was the simplest one, but due to this fact, I think we recalculate the total number of points for case number 5. And on the next lecture, in 2 weeks, I will tell you the new price for case number 5, because I will be able to estimate the difficulty of estimation implied volatility. You have to do it by hands, because now on Moscow Stock Exchange it's impossible to fix it, because options and futures and other derivatives have some difficulties in trading, and due to this fact we have to calculate it by hands, and it will influence, of course, on difficulty of case number 5. And I think it will increase the total number of possible points you will get for this case. Okay, so first of all, we will discuss the notation of forward call, future contract, option, and so on. So first of all, let's discuss the notation of so-called derivative. Maybe some of you know what does it mean, but I think we can write the definition. Let's write that we will say that the financial instrument is called a derivative if its value depends on the price of underlying assets. So it can be commodity, currency, stock, bond, and so on. So its price depends on underlying asset, interest rate, stock index, or other quantitative indicator. One more time. Financial instrument is called a derivative if its value depends on the price of the underlying asset. It can be commodity, currency, stock, bond, and so on. Also, it depends on interest rate, stock index, or other quantitative indicator. This is what is it, the financial instrument. Derivative. Now we will use the notation of underlying asset as some general term instead of commodity, currency, and so on. Of course, the price of a financial instrument depends not only on the price of underlying asset. It also depends on a lot of factors, a lot of additional factors. But the influence of underlying asset is the most significant. The most significant influence is the influence of underlying asset. And always you can find the connection between the functional connection between underlying asset and derivative itself. So for example, if the underlying asset does not exist, it automatically means that does not exist the derivative on this underlying asset. Okay, so here at this moment we want to stop, and we will continue in 2 weeks with case number 5. Okay, bye. Thank you.